what you can observe here is, and the next thing what you can observe, activity 3 you can observe. Activity 3. So what is that activity 3? Activity 3 is explained to understand relation between temperature and kinetic energy. Temperature and kinetic energy. Simple ma. ఇది ఒక చిన్న ఎగ్జాంపుల్ మాత్రం జస్ట్ ఇచ్చిన వాల్యూని అర్థం చేసుకుంటే సరిపోతుంది. Right? There is a hot water in one thing, there is a cold water in another thing. Right? Hot water, cold water is. So hot water ఉంది, cold water ఉంది. అయితే ఇక్కడ ఏం చేస్తున్నామంటే ఏ ఫుడ్ కలర్ లేదా పొటాషియం పర్మాంగనేట్ లిటిల్ గా జస్ట్ జెంట్లీగా దీని మీద స్ప్రింకిల్ చేయండి అంట. సో ఇఫ్ యూ టేక్ ఇట్ పొటాషియం పర్మాంగనేట్ ఆర్ ఫుడ్ కలర్, suppose I have taken food color like this, okay, I gently sprinkle on okay. What you can observe, it is which is a hard one, which is a cold one. Have you seen hard container? This is a cold container. So in this, in which of the containers food color molecules move faster, and why they are moving faster, that you have to understand. సో ఇక్కడ కదే సింపుల్ చెప్పాలనుకున్న పాయింట్ ఏంటంటే టెంపరేచర్ కి కైనెటిక్ ఎనర్జీకి ఉండే రిలేషన్. ఇక్కడ హాట్ బాడీలో మాలిక్యూల్స్ ఫాస్ట్ గా మూవ్ అవుతున్నాయంటే కైనెటిక్ ఎనర్జీ ఎలా ఉన్నట్టు? కైనెటిక్ ఎనర్జీ ఈజ్ మోర్. అండ్ హియర్ మోషన్ ఆఫ్ ది మాలిక్యూల్స్, రైట్? that's very important. Motion of food color molecules. ఎక్కడ ఫాస్టర్ ఉన్నాయి, ఇక్కడ స్లోవర్ ఉంది, దాన్ని బట్టి మనం కైనెటిక్ ఎనర్జీ చెప్పాలి. హియర్ ఇట్ ఈస్ అ ఫాస్టర్, దట్స్ వై కైనెటిక్ ఎనర్జీ మోర్. హియర్ ఇట్ ఈస్ అ స్లోవర్, దట్స్ వై ఇట్స్ కైనెటిక్ ఎనర్జీ ఇస్ low. This is the case. And what about the temperature, where you can expect the temperature to be more, where you can expect temperature to be high? Here temperature can be higher because already we know it's observing in a more temperature. Here temperature can be lesser because it is a cold one. So that's why ఈ అబ్జర్వేషన్ అంతా చూసిన తర్వాత ఏం చెప్పాలనుకుంటున్నాడు అంటే ఒకటే పాయింట్. వాట్ ఈస్ దాట్? the average kinetic energy of the molecules is directly proportional to the absolute temperature, right? So average kinetic energy is directly proportional to the absolute temperature that he wants to prove from this activity, third activity. And not only that, here we need to understand what is this absolute temperature. Why can't it be said as a just temperature? Because it is the temperature value is mentioned in Kelvin scale. So temperature in Kelvin scale is going to be called as what? It is going to be said as absolute. So we have to understand that point. Absolute temperature. That is the activity 3 discussion. Next point, from the activity 4, we want to prove that each molecule's kinetic energy cannot be same for the same amount of heat and chapalanku. So from for that, what we do, let us see now. Now in this picture, figure 1, whatever you have seen, thermometer, two thermometers are there, 2 liquids are there, different hot water and cold water, and lid is there. You see that one thermometer is very specially given to observe the temperature of oil, right? temperature T1, temperature T2 అనుకుందాం. This gives us what? Temperature of oil only. Because you see this lid is immersed only in oil. This lid is immersed in what? So contacting lid is in hot water. That is, this thermometer gives us temperature of water only. Temperature of water only. This gives temperature of oil only. But what we want to understand from this, is very simple. Very simple. So whenever initially the process happening of this activity, if you observe the temperature of this one, right? Temperature of this water initially is 60 degrees Celsius, right? Gently normal room temperature oil is gently poured on water not to mix, right? So gently pour chesam aa tarvata ee setting anta chesin tarvata, if you observe it carefully, what you can see, that's very important to us. So what you can see, that you can observe temperature of one is increasing. That's a T1 is increasing. T2 is decreasing. What is the temperature? T2. Temperature of water is decreasing. Why it happens? Why? Because initially it's a temperature values you have to speak. Water ki 60 undi, oil ki 30 anukuntunna generally. Now if you remember the very basic points, from where to where the heat transfer takes place? Hot body to cold body. Now which is a hot body, which is a cold body here? Water is a hot body, oil is a cold body. So heat transfer takes place from hotter body to cold body. So that one is, you can understand here the temperatures. ఇప్పుడు టెంపరేచర్ రైజ్ అవుతుంది అంటే ఇంకొక టర్మ్ లో కూడా మనం ఆన్సర్ చేయాలి. వాట్ ఈస్ దాట్? సో దాట్ ఈస్ నథింగ్ బట్ previous statement. Remember this? Average kinetic energy is directly proportional to absolute temperature. That's why if the temperature is increasing, what you can say indirectly? Average kinetic energy of the molecules is also increasing. Here, average kinetic energy of the molecules also decreasing, because these two are directly proportional. So what is the meaning of this T1? Right? T1 is regarding oil, right? It is regarding oil. This one is regarding water, hot water, right? So now what we can say? So we can say that average kinetic energy of oil molecules. What happened? Oil molecules is increasing happen. Similarly, average kinetic energy of water molecules, what happened? Decreasing happen. So that we have to, okay, how much kinetic energy, average kinetic energy of oil molecules increased, and how much average kinetic energy of water molecules decreased? That both are same, because which one is lost here, that one is gained there. That's why we can say that average kinetic energy, the loss here equals to gain there somewhere. Loss equals to gain. What is that loss? Kinetic energy loss equals to kinetic energy gain. Means that equals to indirectly again what it can lead? Temperature loss equals to temperature gain also we can understand. Temperature loss is equals to temperature gain. Next. So what is that means? We will discuss in the next classes later. But here is the conclusion. What we want to say from all these? We want to say from all these 2, 3, and 4 activities, This activity, whatever we are discussing, is a 4 activity, right? Activity 4, this picture. Now, from the activity 2, 3, 4, what we are going to say, what is the temperature? What is the temperature? So we already discussed the measure of degree of hotness or coldness, right? That is the temperature. What is the energy? What is the heat? It is a form of energy in motion అని discusses. అయితే heat ఏం డిసైడ్ చేస్తుంది, టెంపరేచర్ ఏం డిసైడ్ చేస్తుంది? Just to make you understand, I will give you a very simple idea. You try to answer me this. Okay, I have taken like this. Here is one, and another one. I have, okay, right. ఇక్కడ ఒక సెట్టింగ్ ఇలా ఉంది అనుకుంటున్నాను. సో దాంట్లో ఏంటంటే ఒక ఫ్లో, ఒక బాడీ ఇలా ఉంది, రైట్? ఇంకో బాడీ సెట్టింగ్ ఇలా ఉంది, ఇంకో బాడీ సెట్టింగ్ ఇలా ఉంది. 2 ends I am giving it, 2 ends A, B of each pipe I am giving. A, B, A, B. These are setting. This is a 1, this is a 2, this is a 3. Now, so involving this 2, 3, 4 activities, మొత్తం conclusion ఈ పిక్చర్ లోనే మనం డిస్కస్ చేస్తాం. You try to understand. It's very important from my point of view. What's the point here? ఈ 3 pictures లో 1, 2, 3 లో ఎక్కడ వాటర్ ఫ్లో జరుగుతుంది? ఒకవేళ ఇందులో వాటర్ ఉండి ఉంటే, if you think that this pipe is filled with the water, where the flow of water can happen? Can you tell me? Flow of water, where can happen? And that too, direction you have to tell. Flow happens or not, right? So, but from where to where it happens, that too you have to answer. Are you getting my point? So there you can understand. In the first case, it is the equilibrium, right? It is equal level. It is equal level. Just there is a very less chances to expect the flow unless there is any external agency. ఒకవేళ మోటార్ ఉంది, ఇంకేమన్నా ఉంది, అది ఎక్స్పెక్ట్ చేయకండి, ఓన్లీ ఇదే మాత్రమే ఆలోచించండి. ఇప్పుడు సెకండ్ పిక్చర్ ని చూస్తే ఇక్కడ హైట్ ఎక్కువ ఉంది, ఇక్కడ హైట్ తక్కువ ఉంది కాబట్టి గ్రౌండ్ నుంచి, సపోజ్ ఇక్కడ ఇలా మీరు ఆలోచిస్తుంటే గ్రౌండ్ నుంచి ఇది ఎక్కువ ఉంది, ఇది తక్కువ ఉంది కాబట్టి ఫ్లో ఎక్కడి నుంచి ఎక్కడికి జరుగుతుంది అని ఇమాజిన్ చేయడం చాలా ఈజీ, రైట్? హైయర్ లెవెల్ నుంచి లోయర్ లెవెల్ కి ఫ్లో అనేది జరుగుతుంది. కానీ ఇక్కడ ఈ ఇమాజినేషన్ లో మనకు ఈక్వల్ లెవెల్లో ఉంది కాబట్టి ఫ్లో అనేది జరగదు. లైక్ దట్ the temperature gradients also, if they are same, means suppose TA is there, TB is there, TA, TB, each of the situation like these temperatures. Okay, in the first case what we am saying, temperature of A equals temperature of B. Will the heat transfer takes place? You have to tell me. Temperature A is greater than temperature of B. Will the heat transfer takes place? Temperature of A is less than temperature of B. Will the heat transfer takes place? From where to where? That should be the clear understanding from these activities 2, 3, 4. So here temperatures are same. That's why it is in thermal equilibrium, right? Thermal equilibrium. That's why no heat transfer takes place. No heat transfer takes place. Now here, higher body to lower body heat flow happens, right? Temperature of A is greater than temperature of B. So the direction will be decided by the temperature. That I want to say from all these activities. Heat transfer takes place from higher temperature to lower temperature. Getting that? So TA to TB heat transfer takes place. What about this case? So here the heat transfer takes place from TB to TA. Why? Because higher temperature is B. Higher temperature is B. Here higher temperature is A. That's why A to B heat transfer takes place, B to A heat transfer takes place. So what's the conclusion? Temperature gives us the idea of direction of heat flow. Are you getting that? Direction of heat flow idea is given by temperature. Whereas heat, right? So if you want to talk about heat, what this gives us the idea? Heat gives us the idea that how much energy, how much energy, right? So you have to, quantity of energy is what? Quantity of energy given by the, that idea is given by the heat, whereas direction of heat flow from where to where it happens will be given by the temperature. These are the two terms, heat and temperatures, what we need to understand, right? I hope you got it, right? So how you felt about these videos also you can express if you like. I mean, if you want to express your comments, you can express in the comment section. Thank you.